Hello, welcome to this lecture video. So today we're going to talk about the Egyptians' rational number, or how do Egyptians write rational numbers, or the unit fraction. So in the previous video, we talked about how do they use 2 all over n table. So they have, just like the multiplication table in our present time, they also have the table wherein it is 2 all over n table, where n corresponds to 5 all over 101, where n are all odd numbers. And then the next one is a splitting method, and the next one is a Fibonacci method. Actually, they do not have particular terms for this method, so they just refer it as a splitting method because it has something to do with splitting. And then for Fibonacci method, it is because of the person behind that method. Okay, so let's first go, or rather, let's first solve a problem, and we are going to use this three methods. So the first one, so let us consider the first one. So the first one is the use of 2 all over n. So we are going to solve 9 all over 13 using the table. So how do they do that? So first, they have to think of a ways on how to convert 9 over 13 into a value or a fractions with 2 all over n. We know, of course, that 2 is an even number. So all even numbers are divisible by 2. So we know that if we're going to remove 1 here, so for instance, the 9, so just to separate the even number, so we are going to add 1 plus 8 over 13. So our objective is to separate the even number, because we know that if we separate the even number, this even number is always divisible by 2. And this is equal to 1 plus. So to convert 8 now to 2, of course, we have to retain the value 2, or rather to get the factors of 8, and that is 4 times 2 all over 13. So which means this can also be written as 1 over 13 plus, so we have 4 multiplied by 2 over 13. So we're done with our objective. Now we have this 2 all over 13. So this can, the value or the unit fraction of 2 all over 13 can be found in the unit fraction table, or the 2 all over n table found in the Rhine Papyrus. And that value, the 2 over 13 and the table, is equivalent to 1/8 plus 1 over 52 plus 1 all over 104. So what's next? So we know that 9 over 13 now is equivalent to 1 over 13 plus, of course, we still have the 4, and then substitute the equivalent value of 2 all over 13. And that is 1/8 plus 1 over 52 plus 1 over 104. And that's it. Okay, next. So we are going to distribute the value of 4, 1 over 13. So multiply. So it is 4/8 plus 4 over 52 plus 4 over 104. So we are lucky enough that 852 and 104 are all visible by 4. So let us remove our first solution so that we can place the equivalent values. So going back here, so we know again that 9 over 13 is equivalent to 1 over 13 plus. So when we round off 4/8, it is equal to 1/2 Plus, if we round off 4 over 52, it is 1 over 13. And 4 over 104 is 1 over 26. Now, we also know that if you still recall, it is a violation to come up with the same denominator or to use the same denominator. So what do we need to do here? So we need to combine this 1 over 13 and 1 over 13. This is 2 over 13 plus 1 half plus 1 over 26. Now, the issue here is that, of course, 2 over 13 is not, again, a unit fraction. So, we need to convert it again to unit fraction. And thanks God, it is in the form of 2 all over n, which means we can just go back to the table and look at the value of 2 over 13. So based in based from the record, 2 all over 13 is equivalent to 1/8 plus 1 over 52 plus 1 over 104. So we will just copy 1 half plus 1 over 26. So this is the answer, but how do they write this? So they have to consider, of course, the lowest denominator is one that I mean 2. It's 1 half plus 1/8 plus 1 over 26 plus 1 over 52 plus 1 over 104. So the answer for 9 over 13 is 1 half plus 1/8 plus 1 over 26 plus 1 over 52 plus 1 over 104. Again, if you still recall the discussion of the possible rules followed by Egyptians, so it was also mentioned in the previous discussion that they just limit it into 4. So which means if we are going to assess our answer here, it's 1 half, 1/8, 126, 152, 1 over 104. So it contains 5 terms, so which means maybe they will still do something about it. But since there is no written rule except for the observation about that number of terms, so we can simply follow this as our final answer. Okay, so this is how to use the 2 all over n. So again, what you need to do is to separate, if you are provided with an odd number, so what you have to do is to make sure that you're going to remove 1 and retain the even numbers so that, of course, it can be converted into 2 all over n, wherein you have to look at the table for you to use that. So as mentioned, we are just lucky that we have here whole numbers, or rather it is the denominators are divisible by the numerator 4, or else we need to redo the process over again. So just like what we did here, we considered or we used the 2 all over n twice. So it is when we obtain the value 1 over 13 plus 1 half plus 1 over 13 plus 1 over 26. So however, since 1 over 13, so we have 2 terms for that, we have to combine that and again do the same process by finding for the values of 2 all over n in the table. Okay, next. So how about for the splitting method? So this is the splitting method. So if you are provided with 1 all over n, or you have 1 over n, so you can convert this using the formula. So it's 1 all over n plus 1 plus 1 all over n multiplied by n plus 1. So why do you need to do this? So remember that as mentioned before, they cannot or you cannot use the same number or the same denominator. So for instance, for 2 all over 13, we cannot use 1 over 13 plus 1 over 13. So you have to find for the value of what is 1 all over, what will you do to change the value of 1 all over 13? So let's have an example for this. Okay, so let's consider 2 all over 19. So this is equivalent to 1 over 19 plus 1 over 19. So as mentioned, we cannot use a duplicate denominator or more than two denominator with the same value. So we have to convert 1 all over 19. And based in our formula, 1 all over n is equal to 1 over n plus 1 plus 1 all over n multiplied by n plus 1. So which again means that this can be written as 1 over 19 is equal to 1 over 19 plus 1 plus 1 over 19 multiplied by 19 plus 1. So simplify further, so which means that 1 over 19 is equal to 1 over 20 plus 1 over 19 times 20 is 380. Now let's go back to our first solution. So here. So which means, so we will go back to our problem. So we wanted to convert 2 over 19 into unit fraction. So 2 over 19 is equal to, so let us copy 1 over 19, plus of course, what is the equivalent of 1 over 19? It is 1 over 20 plus 1 over 380. So this is the equivalent value of 2 all over 19. So if you considered, for example, the same procedure as what we did in solving, so let's go back to our problem. For solving 9 all over 13, for instance, so we have the value, so we remove 1 over 13, bring out 4, and then 2 all over 13. So you have another option to change the 2 all over 13 here. And that is, so 1 over 13 plus 1 over 13. Using the splitting method, this can be written as 1 over 13 plus 1 over, what is the formula? It's n plus 1 plus 1 plus 1 over n multiplied by n plus 1. So that is 13, 1 over 13 plus 1 over 14 plus 1 over 13 times 14. So what is 13 times? Let us multiply 13 times 14. It's 182. So it is equivalent to 1 over 13 plus 1 over 14 plus 1 over 182. So it's another procedure. And then you can go back again to 1 over 13 plus 4 multiplied by 1 over 13, 4 over 13 plus 4 over 14 plus 4 over 182. But again, your problem is, how will you convert 4 over 13 again into unit fraction, because it cannot be rounded, 4 over 14 and also 4 all over 182. So actually, in solving this problem, you really need to, it can be redo the process. You can use a combination of all the process, so just like here, or you can use the table the 2 over n table, you can also use this process. Okay, so now let us consider that